Hello grade 12s, welcome to my channel. Let us have a look at this question 2, which is on Newton's laws of motion. A very common topic in every single physics exam you are going to write this year. So we might as well just get it done and see how to deal with questions of this nature. Now what is important, guys, this is mainly a topic from grade 11, and essentially we need to have the strategy. At the same time, our awareness has to be on high alert. Okay, we cannot be complacent at all in this subject because it applies a lot of maths. At the same time, it requires a whole lot of interpretation of information that is provided, and we need to be very precise because any vague attack here results in tears. Okay, now question 2 reads, it's from one of the prelims of last year, from the Northwest to be specific. Now two blocks of masses 9 kg and 4 kg are connected by a light inextensible string. Now we need to understand the significance of this light such that the weight of the string is not considered a part of the weight in the system, right? The inextensible nature of the string is to suggest that when one block moves, and so will the other at the same rate, okay? Because there's no dissipation of forces, or at least the forces that they will experience are pretty much, should we say, similar or the same. Let's say if we apply resultant force here, it will affect the entire system the same way, okay? Now a constant force, very important, constant force acting at 75 degrees to the horizontal is applied to the 9 kilogram block as shown in the diagram below. We can see the arrow. So what is important is to focus on that arrow. In which direction is it? Because the arrow tells us the direction of the force's action. Sometimes the length may suggest the magnitude, but we don't really attach so much importance into that at grade 12. Alright. Okay, alright. Now, the string runs over a frictionless pulley. What's the significance of the frictionless pulley? It is to suggest that the tension on that side of the string should be the same as the tension on that side of the string, okay? Pretty much giving the same knowledge as that of the inextensible nature of that string. But more importantly, it is to suggest that there's no friction here, meaning the tension on one side of the string is definitely equal to the tension on the other side. Okay, not a problem. And then we're told the 9 kilogram block moves at a constant velocity of 4 meters per second. Now, question is in which direction? If we look in the diagram, we'll see that the arrow of that velocity is pointing to the left. So these are things that you may miss if you read this in a hurry and you just start answering questions without understanding the actual scenario given. So physics is not one of those subjects you just jump in and go. Of course, there are some areas where you can, but most of the technical questions like Newton's laws of motion, vertical projectile motion, you're thinking about issues of current, electricity, we're looking at electrostatics, mainly those 4 topics, or work energy theorem, and essentially work energy and what is this? Yeah, it's actually momentum, energy, and power. Used to combine those two, but now it's just called momentum. So those 5-6-ish topics, one has to pay a particular attention to the exact information given, and even think beyond that, see the implications behind the statements given. Some things are just direct, certain things are indirect, and in fact most of the time a lot of information is given indirectly. As we can see here, this is moving, but nobody specifies which direction. But if one studies the diagram carefully, you will also notice that the arrow is going to the left. So we can see that the system is moving in that direction. So that's the direction of motion. Okay, very important to look at things and look at them good. While experiencing a frictional force of 2,5 newtons, and of course this 2,5 newtons is not indicated, we need to show it. So there is the 2.5 newtons, and it's what we call the kinetic friction, because friction to a moving object is going to be kinetic friction. So this is very good. Okay, so we need to then state Newton's first law of motion. That's very easy. Let's start. So 2.1, what is the story here? We are told here that a body will remain at rest or continue moving at constant velocity unless acted, maybe let's write it properly, unless it is acted upon by an external resultant force. Okay, very important. Key here is either it remains at rest or it moves at a constant velocity unless an external resultant force acts on that object to change its state of motion. So again, guys, these things need to be more like a restation in kindergarten or in the elementary levels, because understanding these kinds of, should we say, principles or laws, it helps us to then deal with the questions. Because if this is the law being asked, it means this law applies in this question. So we need to be careful. Now, one of the most important things about Newton's first law, it simply means the resultant force is essentially zero here, except when this, you see, the very first bulk of the statement is suggesting that the resultant force for Newton's first law to apply must be zero. The moment there's an external resultant force, then Newton's second law kicks in. So these two are almost inseparable, because within this definition, once we talk about an external resultant force, we're already suggesting Newton's second law will kick in should there be such a situation. Okay, we need to draw a labeled free body diagram for the 9 kg block. So often we use a dot. We used to use a block. We called it a force diagram, but yeah, whatever. Anyway, guys, first, the easiest force to deal with here is the weight of this object. It's always going to be straight down. And the weight is accepted as Fg. So there's no need to explain what that is, okay? Good. And then we are going to have an opposing force to this. Now this force is going to be the normal force. Capital letter N is accepted to denote the normal force because we never use N in physics for anything but the normal force, unless we are dealing with something else. Like in electrodynamics, N would represent the number of turns, stuff like that. Okay, so what is the next thing? We know the tension is pulling in this direction. So we will have the tension, capital letter T in physics, in this particular topic, is accepted to represent the tension. So there's no need to write that in full. We are going to have friction. We don't really care how big the friction versus the tension. It's going to be in the direction opposing the direction of motion. So if we write small letter f and a subscript k, so f sub k, this it always represents kinetic friction in this topic. Okay, now there's one force that we need to think about now. It's this force that is being given. Now remember, with a free body diagram, I have not seen a force going into the dot, but the force must be going away from the dot because its effect is going to be pulling, even though this is pushing, but yeah, whatever. I don't know what happens when you put that force in there, but it's best to shift that force. So again, from grade 11, you have learned how to shift forces. That F, sometimes some people may write F sub A, which is FA, applied force, but at this point, just F is good enough because that's what we were given. Now, do we need to worry about the angle? Maybe. Now, if we just work on the diagram a bit, we will see that if we extend this force right on its direction, right, and then we extend the horizontal as well, across like that, we'll appreciate that this angle will be equal to that angle. These are vertically opposite angles. Now, when we essentially consider the weight, now we're going to look at this force as acting at the center of this object. If we say this is the vertical, right here. Now we know that this is going to be 75 degrees. But now if that is 75, we know that this whole angle should be 90 degrees, right? So what should this angle be? 75 plus what will give us 90 degrees? It's going to be 15 degrees, isn't it? Yes. Am I lying? 75 plus 15. Why am I doubting myself here? That should be 15 degrees. So someone may show this angle if they like, but there's no need, honestly. So this should be 15 degrees. If you show it, please show the correct angle. To the vertical, it's going to be 15 degrees. All right. Okay. All right. So this is essentially the forces that we need to show. And for each, we get a mark. Can you see? Easy 5 marks here. But if you use symbols that are not identifiable in the standard exams, you may have to write a short key where you explain which force is which, or perhaps write those names in full. But if you use these symbols that I have shown you, those symbols are acceptable because they have a meaning in our standard exams. So don't be writing anything in full and you end up writing stupid things or wrong things. Now calculate the magnitude of the force acting on the 9 kg block. Of course, this question is not a standard grade question. So it's a higher order question. So obviously, folks, Simultaneous equations. Didn't I tell you in the math summary, doing the math paper 2 from grade 12, 2024 final exams? Of course, guys, I'm not going to keep repeating these. If the video is there in the channel, please watch it. I know those videos are long. A lot of South Africans are lazy people. They don't like to read. Number 1. 2, their attention span is crazy. They do not pay attention. They don't like to pay attention. But here's what is funny. They actually give attention where it's not necessary. Like social media gossip, trends, reading about nonsense, watching silly things, talking to friends endlessly. They concentrate there, talking nonsense and gibberish. But give them information, they shut off. I don't know why they're so anti-information. Secondly, you are giving them a very free lesson here for 6 hours, non-stop, free of charge. Imagine how much they would have to pay if you were to charge every hour of that 6 hours, because I could be doing very important things in my life in those 6 hours. But I take time to give you guys a bit of a lesson so that you can learn to be the best. And now all you do, you cry about, this is too long, I'm not going to watch it. And then you fail the exams. Then you go and cry, this thing is too difficult, I don't know if I'm going to make it. But you are not serious about wanting to know, because here's the information for free, for mahala. Imagine the time you waste going to certain classes where you don't benefit anything. Now we're bringing these at the comfort of your home, on your smartphone, right in your hand. All you have to do is just to watch, but not just watch carelessly or passively. You should be taking notes and participating. Sometimes you freeze this thing. It's user-friendly, by the way. You freeze it at will. You attempt whatever part of the question you feel you can. Because remember, not every question here will be so easy for you to attempt. Maybe you might want to see me break it down at first. As soon as I've done the breakdown and now you fully understand, you can freeze the thing. And then attempt all the questions. And then unfreeze the thing and see what I'm doing. And the good thing is you will even pick up mistakes that I'm committing rather than to believe them because you think I'm right. You'll also see where your weaknesses are and start making notes in your brain, because notes, guys, must be something that you realize, something that you get to understand, the gist of it all that you get, not just a reproduction of what is written. Those are not notes. That's actually cramming, but very passive way of cramming, because in my opinion, it doesn't stick in your brain. You still have to commit it to memory first before it can stick. So you might as well just cram it right from the book than to waste time writing it down. Anyway, whatever. Let's not get into the politics of studying and stuff. Let's just get to the business of the day. Now, for us to calculate this, remember the vertical forces. Now you're not gonna write this in the exam. So if this object is not going down and it's also not being lifted off, this force balances the vertical forces. But remember, this is acting at an angle. So these two are not equal. The normal force is bigger than the weight in this case, because the weight has the vertical component of this force, which is going to be straight down, right? And so it adds up to the weight to balance the normal force, or the normal force has to balance two forces opposing it. So remember that. Don't make the mistake of thinking these two are equal. But in the free body diagram, we don't really care for magnitude of the forces per se, but sometimes think about it though. Do think about it. In fact, it brings me to trying to adjust this, because it looks as if they are equal and they are not. Let's make it a bit shorter. Okay guys, so that's it. Now, what are the forces that are of importance here? Because we know the vertical forces are not really going to help us. But now we need to think about forces that are very useful. Now, the forces that are very useful in this 9 kg block. Okay. Let's do the 9 kg block. Here, I will just do the force diagram because I think it's better. Now, we're going to have the tension. We're going to have the kinetic friction. And essentially the horizontal component of that force acting. So this is going to be F in the x direction, or F sub x. Remember, these are subscripts. It's not F multiplied by x. Okay, be very careful. Carelessly we read Fx, but it's actually F sub x, because that is just suggesting the direction of that component of the force F. Okay, so that's all we have, guys. Is there any other force I'm forgetting? Not at all. But are we only going to need this? The answer is no. We need something else, because how will we know what the tension is? Now we also need to consider this 2 kg block. This one, luckily, only has 2 forces acting on it. So these ones are exactly balanced. Don't worry about the fact that they don't look to be balanced. Okay, maybe they will now. So here we've got the gravitational force of the 2 kg block, and we will have the tension. And remember, this tension is the same as that. But now this tells us a beautiful piece, that if the 9 kg block moved at constant velocity, the resultant force to it is 0. But can you see there's lots of unequal forces, but all of them added together, they give us 0. But the nice one is this one right here, because this already tells us, in fact, it's a 4 kg block, not 2. Lord. So this already tells us that if Fg can be calculated here, it exactly is equal to the tension, but in the opposite direction. And so we will have a solution to that. So here we just say 4 multiplied by 9,8, which is going to give us that weight. So this is 4 times 9,8. This is 39,2. So if this is the case, in magnitude, 2 forces that exactly balance each other are equal. So that's 39,2 as well. Newtons. Don't know why I wrote kg here. Holy crap. Holy crap. Sorry for the choice of words. Some people are too sensitive. They cry easily. They get horrified easily. And it's a rough world we live in. So we need to just get on with it. So guys, if we've got 39 there, it means our tension is also going to be 39,2 newtons. So do you see the most important piece is frictionless pulley, giving us that piece that the tensions are literally the same thing. And now we're using the 4 kg block to essentially get the value of the tension. Then we can deal with these forces, because we know this one is 2.5 newtons. So we now want to just determine what that force is. But we know that the sum of these 2 forces, if this body is moving at constant velocity, must be equal to that force. So can you see, this is very easy, because now we know that this force in the x direction, the component of the force applied, is essentially going to be equal to the summation of the tension and the kinetic friction, so that this body can move at constant velocity to the left, because the vertical forces don't play a part in this particular block. Easy, ne? But now we need to think about the direction in which this is. That's very easy, guys, because I mean, it's at 75 degrees to the horizontal, this thing. So we're gonna deal with it nicely. Okay, so let's leave this. Now let's get to the calculations. Remember, this is just my breaking down of the situation. This is the best time for you to pause the video and attempt the calculation, because at times you're not so sure as to how to get things. But at first, you want to take it easy. Learn to see how things are structured first. Then you can do the calculation, which is the easy part, when you know what is going on. After that, you then start taking a new question. You break it down yourself. You try and understand every little piece in it. Don't be in a hurry. I know you always chase time because you are told, work on your time, set time. But remember, guys, you only set time when you are ready. You don't set time when you are not ready. You are still learning. You set time when you are ready. While learning and studying and trying to understand what's going on, you just take your time. Okay? Don't be counter-revolutionary comrades. Be the revolutionaries. Be as radical as possible. Then you finesse how you do things once you know. Then you can economize, because it's easy to economize when you have knowledge. Think about it. When you have money already and you can afford things, you economize better than someone who does not, because they don't have money to begin with. So once they have a little bit, it's easy to blow it, because they think, yeah. Because, I mean, they have not afforded many things in life before. It's even easier to, tighten your belt and say, I'm not going to buy 1, 2, 3, because you're not under pressure to have it, because it doesn't feel like it's a necessity anymore, even if it is. But when you don't have money, boys, once you bump into some money, you buy everything you thought is important, and sometimes certain things are not. Anyway, let's not talk nonsense. Now that you have attempted the question, I believe you probably have an answer. Now let's get into the business. Now remember, we're going to use Newton's second law of motion when we do these calculations, but we need to start with the tension. So we will say here, sometimes some people divide this and say for 4 kg block, you know what I do? Let me just show you what I do. I just jump in, but derive simultaneous equations. I will say the resultant force is equal to mass times acceleration. Okay? Now this implies that the force in the x direction, the component of that force in the x direction, plus the sum of these two forces, the tension and the frictional force, should be equal to mass times acceleration. Okay, we move on and say this implies this is the F in the x direction. Of course, at this point we can decide to, use a triangle rule of trigonometry. Remember, this forms a triangle, so to speak. Right? So this is going to be the force in the y direction, whereas that becomes the force in the x direction. And guess what? The angle is still that 75 degrees. Okay? So this is good. And remember, this is 90 degrees. These are the perpendicular components of this force, meaning they are perpendicular to each other. So that angle should be 90 degrees. I hope you can see. Now, folks, look at that triangle. So if you look at that triangle, it's a right angled triangle. So if we want that one, we know the hypotenuse side is the force F, right? This is the force F, and those are the components of that force in the two directions, but we're interested in the x direction. So this is going to be sine 75. It's going to be, no. This is going to be cos 75, right? And now if we say cos 75 degrees here, it's going to be the adjacent, which is going to be the F in the x direction, over the hypotenuse, which is the actual applied force. And therefore we know that our F in the x direction, when we cross multiply F there, it's going to be F cos 75 degrees. So this is what we're going to take down here and plug it here. So we're going to have F times cos 75 degrees plus. Now remember, the other thing I forgot to mention, we need to choose a direction. So we will choose to the right, to the left as positive. So always make an attempt to choose the direction of motion as positive. It makes life a lot easier. This is very important, because if we haven't made a choice, it can get very difficult for you as a student and sometimes the marker to follow you. Now this is opposing that force. Now these are going to be negative, so it's going to be minus, minus tension, because we don't know it yet. Don't worry about that, we calculated it there. That was not answering. Then minus 2,5 equals 9. What's the acceleration? We were told that this is doing constant velocity. Now constant velocity simply means acceleration is 0. Okay? As well as the resultant force is going to be 0, because these two are related. So this is 0, like that. We continue. This implies that F cos 75 minus tension minus 2,5 is going to be equal to 0. See? Do you see? Now we transpose what we don't want. We can say this implies also that F cos 75 degrees is equal to tension plus 2,5. We can say therefore F is going to be tension plus 2,5 all divided by cos 75 degrees. But this is not over, because now we don't have our tension. Did I really finish the page? We can say, however, we know that basically we know that the 4 kg block, so we know that 4 times 9,8 plus the tension should be 0, isn't it? Because those two are not going to have a resultant force. This is more or less the same thing, but I'm just trying to avoid doing the same thing. Now we know that this is for the 4 kg block. So what does this mean? It already means that I'm trying to think, maybe let's say minus the tension, because now these two, as much as we add the vectors, but remember the direction of motion we chose as positive, so it means up here is going to be positive. So we can put a minus there. That should give us 0, and therefore we know that the tension should be 39,2 newtons. This, when we're using the kg, we're using the 4 kg block. Okay, easy. So we can then do our force and say, therefore, our force is going to be 39,2 plus 2,5 divided by cos 75, which is going to give us the answer. So 39,2 plus 2,5 are 39,2 plus 2,5 divided by cos of 75 is 161,12 to 2 decimal places newtons. But remember, the question said magnitude, so nobody cares about the direction. You can leave it. But I will teach you that even though it's not mentioned, write it in brackets. This is 75 degrees to the horizontal. Add 75 degrees to the horizontal. Okay, let me not be silly, guys. What is that angle? This is 15 degrees from south to the west. So konje bhalwa kanjani? 75 degrees at 75 degrees west of south. Always be in the habit of writing the direction. Even if it's not correct, it's not going to spoil the answer. When the question is on magnitude, the first answer is the magnitude. Alright guys, so I took a bit of time so that you can follow. Otherwise this could have been done in just 12 minutes, okay? Once you know what to do. Of course guys, in physics we get a mark for the formula, right? This is some determination on its own, so be very careful of these kinds of things. That is some determination and the general substitutions, right? Right. And getting the value of the tension was key. And finally the answer. So this is how we score those 5 marks for a total of easy 12 marks in this question. So I hope you guys have enjoyed the video and you can see the skills necessary to deal with questions on Newton's laws. And I can tell you guys, drawing these force diagrams is key, because without them it becomes very difficult to figure out what to do and how to do it. Okay, because issues of signs are going to overwhelm you, and issues of what is this thing? Yeah, doch. Issues of formulae as well and what to substitute can overwhelm the students. So there's clues. Always study everything that's given and take your time to figure it out. Okay. Anyway, guys, this is too long. I didn't want to make it long, but I had to make sure you understand every step that we take, so that if you have attempted this question before you started seeing my solutions, then you can understand what I'm doing and what you should be doing. And this becomes a lot easier with more and more practice on questions of this nature. Otherwise, leave a thumbs up, consider subscribing, and let's keep learning so that you can be the best and get to that favorite degree of yours that you think is best in life. Or perhaps this may even open even more options than you ever thought for yourself. Anyway, guys, whatever it is that you want, it is your choice and it's upon you. But don't just watch. I'm not a TV producer. I'm not creating a movie for you to watch. I'm just giving you an idea on how to deal with issues that pertain to your studies, so that you can do it better and so that you can thrive. I'll see you next time. Bye-bye.